Hello and welcome to 3 Dimensions. In this channel, we will be discussing problems from NCERT, outside-based problems and uploading videos. So in this lecture series today, we'll be dealing with example questions from chapter Units and Measurements, which is part 1 Physics. So let's start. Let's solve example 2.1. So the first part of the question is, calculate the angle of 1 degree in radians. So using the given information, we are supposed to solve the part A question. So the question here is, convert angle of degree into radians. So using the given information, 360 degree equal to 2 pi radian, you have to solve this. So how do you find 1 degree from this above equation? So divide both the sides by 360 degree. What do you get? 1 degree equal to 2 pi by 360 radians. So once we simplify this equation, we get 1 degree equal to pi by 180 radians. So we get this is equal to 1.745 into 10 power minus 2 radians. Now let's solve part B of the question. So this question here, part B, is convert 1 minute into radians. So the given information here is 1 degree equal to 60 minutes. So the question here is, what is 1 degree, right? I mean, where do we get 1 degree from? But that is what we solved in part A. So part A, we got 1 degree equal to pi by 180 radians, or 1.745 into 10 power minus 2 radians. So insert that value over here. So in place of 1 degree, we write pi by 180 equal to radians is equal to 60 minutes. Now how do you find 1 minute from this? Divide both sides by 60. So you get 1 minute equal to pi by 180 into 60 radians. Or 1 minute equal to 2.91 into 10 power minus 2 radians. Now, before you check out the part 3 of this question, try to solve it on your own. Using the same method as part A and part B, try to solve the third part. Alright, so let's solve part 3 of the question. Over here, we have to convert 1 second into radians. 1 second of an arc into radians. So what is given here is 1 minute equal to 60 seconds. Like before, what is 1 minute? So we have solved that in part B. So insert that into part C. So you get pi by 180 into 60 equal to 60 seconds. So how do you find 1 second from this? Divide both sides by 60. So you get pi by 180 into 60 equal to 1 second. Or this is equal to 4.85 into 10 power minus 6 radians. The question here is, a man wishes to estimate the distance of a nearby tower from him. So he is at point A and the tower is at point C. It is, this tower is in front of him. So let's draw this. AC, the distance between that is what we have to find out. Okay, then he says he then walks perpendicular to AC up to B. Next, it's a distance of 100 meters. So from this point and looks at O and C again. So it says from B it looks at O and it looks at C. So we know there's a distant object O there, okay? From when you observe from O, O is a distant object. So when you observe it from A or B, because O is a very distant object, we feel that AO is approximately equal to BO. The distance AO and BO is approximately the same. So, but he finds the line of sight of C shifted from the original line of sight by an angle theta. Okay. So what is the line of sight? So line of sight is the line between the observer's eye and a distant object. The line between them is known as the line of sight. Okay. So we see that from B, he has observed O and C. So any notices that the line of sight of C has shifted by 40 degrees. So that angle over there is 40 degrees. That is the parallax angle. So from B to C, the angle is 40 degree. So once you've drawn the figure, now how do you solve the problem, right? So we see here it's a right angle triangle. We can use trigonometry here to solve the question. The question here is AC, the distance between the man and the tower. So let's go. Tan theta equal to opposite side by adjacent side. So what is the opposite side here? Opposite 40 degrees, AB. What is the adjacent side here? AC. What is theta here? 40 degrees. So tan 40 degree is equal to 100 meters divided by the unknown variable AC. So how do you find AC? 100 by tan 40. What is tan 40? 0.8391. So we get the value of AC to be 119 meters. 119 meters. Example 2.3. The moon is observed from two diametrically opposite points A and B on Earth. So let's draw this. Let's draw the Earth. Now let's draw the moon. Okay. So two diametrically opposite points, they are observing the moon. Okay. From points A and B, they are observing the moon at a point. Okay. So the angle theta subtended at the moon by the two direction of observation is 1 degree 54 minutes. So that theta value there, the parallax angle there, it is 1 degree 54 minutes. Okay. And given the diameter of the Earth to be about 1.276 into 10 power 7 meters. Diameter of the Earth is that value, 1.276 into 10 power 7 meters. Now the question here is, compute the distance of the moon from the Earth. The value of D is what they are asking. What is the distance of moon from the Earth? So we are using a method called the parallax method to solve this question. So what is this parallax method? Now keep a pencil right in front of you. Okay. So do this experiment along with me. I want you to close your right eye. You observe that the pencil has shifted to a different direction when you're observing with your left eye. Now close your left eye and observe with your right eye. We see that the pencil has shifted to a different position, right? So this is known as the parallax. Now how do you calculate and why do we need this? This is used to calculate distance of faraway objects like the sun and the earth, the sun and the moon. The distance between the eyes, that is given by a basis. So basis B. The angle subtended to the pencil, that is given by theta. The distance between the eye and the pencil is given by D. So how do you find D? D is equal to B by theta. So that is the formula. Now use this formula to solve the question. So we have got theta, we've got B. The only question here is what is D? So using this formula, find the answer. Now theta is given as 1 degree 54 minutes. We want both of them to be either in degree or in minutes, right? We know that 1 degree is equal to 60 minutes. We solved this in example 2.1. Okay. So we can write 60 plus 54 is 114 minutes. So theta is equal to 114 minutes. All of this calculation, we need to do it in radians. So convert the theta into radians. So say from example 2.1, you solve this. So convert the minute into radians. So that is theta is equal to 114 into 2.9 into 10 power minus 2 radians, or 114 into pi by 180 into 60. That is how you find the minute value. Now how insert these values into the above equation. D equal to B by theta. So 1.276 into 10 power 7 divided by 114 into 2.91 into 10 power minus 2. We get the final answer to be 3.84 into 10 power 8 meter. That's our example 2.4. The question here is, the sun's angular diameter is measured to be 120 seconds. The distance d of the sun from the earth is 1.496 into 10 power. What is the diameter of the sun? So let's draw it. Sun, the earth. You have to find out the diameter of the sun. The angle subtended to the earth is 1920 seconds. So, but it's in seconds. Now we have to convert this into radians. Okay, so theta value is in seconds, but you should, when you're doing calculations, always convert it into radians. So theta is equal to 1920 into 4.85 into 10 power minus 6 radians. Okay, so this we solved from example 2.1. So just refresh back by going and checking out how you did it. Now what is the value of d? That is what you just find out. So from the previous example we saw, using the method of parallax method, we can find the value. So what is d here? D is equal to b by theta. What do we need to find out here? B. Okay, so b equal to d theta. So what is the value of d here? 1.496 into 10 power 11. What is the value of theta here? 1920 into 4.85 into 10 power minus 6. So do this calculation and you find out the value. That is 1.39 into 10 power 9 meters. Example 2.7. We measure the period of oscillation of a simple pendulum in successive measurements. The readings turn out to be 2.60, 2.56, 2.42, 2.71 and 2.80. Calculate the absolute, relative or percentage error. So now, how do you find out the absolute error? This can be found out in just 3 steps. So okay, let's find out how to do that. So the first step here is you find A mean. So what is A here? The value A is this, as given in the question, 2.63, 2.56. All of these are A values. Okay, all of these values are A. Now you have to find that the A mean. How do you find the mean? You add the sum of all the values given, that is A1 plus A2 dot 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 plus till the last value divided by the total number. So that will give you A mean. Okay. Now let's go to the, over here the n is equal to 5. Okay. This will give you the A mean value. Now let's do the part 2 of this. Okay. What is the second step? The second step is you have to subtract the value from the mean value. So we found the mean value before. So suppose this is A dash. Okay. So we have to do this for every single value that has been given. So we do it with A2 minus A mean, that is be A2 dash. So these values can be either positive or negative. Okay. If A2 is a smaller number than A mean, we'll get a negative value. If it is greater, A2 is greater than A mean, we'll get a positive value. So that's a second step. And the third step, the final step, all we have to do is add all these values. Add A1 dash plus A2 dash plus da 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 till AN dash. But all of these are absolute value. So what is absolute value? So even if suppose A2 dash is negative, we'll get a positive value. Okay, and this will be divided by the total number. So we get delta A mean. Okay, so we get the absolute value mean. The final answer we write it as A mean plus, so A is equal to A mean plus delta A mean. So this absolute error, this delta A mean is the absolute error. Now how do you find relative error? This is it. Okay, the absolute error is found. Delta A mean is the absolute error. Now how do you find the relative error? The relative or the percentage error is simple. All we have to do is just once, it's a one step. Okay, so all we have to do is divide the absolute mean value. Okay, that is delta A mean value by the A mean value. So let's see how it is. Relative error is equal to delta A mean divided by A mean. Now, how do you find the percentage error? Simple. All we have to do is the relative error multiplied by 100, that is the percentage, that is what you get the percentage value, you will get the percentage error. So this will give you the percentage error value. Now let's go to solving the question. Now using these steps, try to solve it on your own. But right now I'll give the explanation, but if possible, pause the video here, try to solve it on your own. So let's see this. Okay, so what are the values given here? What is A1? That is 2.63. What is A2? 2.56. A3 is 2.42. A4 is 2.71. A5 is 2.80. So we see that N here is 5. There's 5 values here. Now this A is equal to T, time period, because they've asked we measure the period of oscillation. So what you have to find here is the mean time period. Okay, so we're finding A mean or T mean. Okay, the mean of the time period. That is what you're trying to find here. So since we've already learned A mean, we'll be using that right now. So first question, how do you find the absolute error? So using the 3 steps, what is the first step? Find the T mean or A mean. This is equal to add all the values that is given to us, A1 plus A2 plus A3 plus A4 plus A5, and you divide it by the number of values. That is, here it is 5. So once you do this, you get the value. That is, you add the sums, add the values. (2.7 plus 2.80) divided by the total number. We get the final value to be 2.62 seconds. That is the T mean value that you have here. Alright, now let's go to part 2. Okay, what is the second step here? Now the second step here is subtraction. So we are going to subtract A1 from A mean value or T mean value. So T1, the first time period value, minus the mean T value. So what do we get? Let's see what steps it do. Here. So the first value here was 2.63. The mean value is 2.62. Subtracted, you get 0.01. Do this for the remaining 4 of them. Okay, so 2.56 minus 2.62, that will give you negative 0.06. 2.42 minus 2.62 will give you negative 0.20. Now, for the next one is 2.71 minus 2.62 will give you minus 0.09. 2.80 minus 2.62 will give you 0.18 seconds. Now, what was the third step? We add all of these values. Okay, we add all the above values. The subtracted values, we add all of them. You divide it by the number of them and you get the absolute error. But here, what you do is, what is absolute? Even if it's negative, we take the positive value. So 0.01 will be 0.01. Negative 0.06 will be positive 0.0. This dash, the 2 lines that you see, is indicating the absolute value. You add all of these, divide it by 5, and you get the final answer. That is 0.54 divided by 5. That will give you 0.1 second. Alright. Now how do you find the relative error? Alright, let's write normally. So once you've done this, you write it normally. So that is T. Okay, the value time period T is equal to T mean plus delta T mean. Right? So that is 2.62 plus or minus 0.1 second. That is your T value. Your time period is this. Now to the next part. How do you find out the relative or percentage error? Right? So for this it's simple. All we have to do is divide delta, the absolute error, divided by the mean value. So the absolute error here is 0.1 divided by 2.62. That will give you a value of 0.1 divided by 2.6. That will give you a value of 0.037. That is the relative error. Now what if you want to find out the percentage error? So how do you find the percentage error? We just have to multiply by 100. But then we get 3.7 percentage. But since it's 7, we can round it off to